Welcome to our lecture online. In this video, we're going to show you how to find the general range equation of a projectile. In other words, how far will the projectile go before it lands on the ground? What is the general equation? We're not going to use any numbers. Again, the initial velocity is v sub naught, which gives us the initial velocity in the x direction and the initial velocity in the y direction in terms of the angle theta, and of course the magnitude of the initial velocity. The way to solve this problem is to solve for time in the air both for the x and the y direction. So using the y direction first, time in the air, we're going to use the equation y equals y sub naught plus v sub naught in the y direction times time plus 1/2 gt squared, remembering that g is a minus 9.8 meters per second squared. Plugging in the numbers, final height 0 when it lands on the ground, initial height 0 when it leaves the cannon here, plus v initial in the y direction, which is v initial times the sine of theta multiplied times t, and a minus, well, leave it as a general term. I'll just go plus 1/2 gt squared, of course, realizing that g is a minus 9.8 meters per second. And then here I can factor out a t. I get 0 is equal to t times v initial times the sine of theta plus, I don't need the parentheses there, plus 1/2 g times t. Now what I'm going to do here is solve this equation for time. Since it's set equal to 0, that means that t is equal to 0. That means it hasn't left yet and it's back on the ground. Or I can write that v initial times the sine of theta plus 1/2 gt is equal to 0. What I'm going to do now is do the same in the x direction. So time in the air for the x direction. The equation, just like before, here in the y direction, we have x equals x sub naught plus v sub naught in the x direction times time plus 1/2 a in the x direction times time squared. But in the x direction, we can say that x sub naught equals 0. That's the initial position where it starts. And there's no acceleration in the x direction. This equation reduces to x equals v initial in the x direction times time. And v initial in the x direction is defined here. So x equals v initial times the cosine of theta times time. And of course, x is the range, so we can replace x by the range, the distance we're looking for. So the next step, notice that we have here the range defined in terms of the initial velocity, the angle, and time. And here we have an equation that relates t to g, v initial, and the angle theta. So what we could do is we could solve this equation for t and plug that in the t over there. Let's go ahead and do that. That gives us the following. We get 1/2 gt is equal to the negative v initial times the sine of theta. And then if we multiply both sides by 2 and divide both sides by g, and remember that g is a minus 9.8, so if I make that into a positive, I can get rid of this negative sign, which means we come over here that t is equal to v initial, or actually, I'll bring the 2 across, 2 times v initial times the sine of theta divided by the absolute value of g. So we solve this for t, bring the 2 across, bring the t down here, make an absolute value of g, and the negative disappears. Now we're going to plug that into our equation up here. So this t goes into our equation over here, and we get the range is equal to v initial times the cosine of theta times this quantity, which is times 2 v initial times the sine of theta, all divided by the absolute value of g. Now I see a 2, a sine of theta, and a cosine of theta, and I realize that 2 times the sine of theta times the cosine of theta is actually equal to 2 times, not 2 times, but it's equal to the sine of 2 theta. So I can replace this, and this, so the cosine of theta, 2, and the sine of theta, by that, and I could then say that the range is equal to v initial squared, because I have a v initial times the sine of 2 theta, all divided by the absolute value of g, and that'll give us an equation that gives us the range for any projectile starting from the ground reaching a particular distance. Notice it's simply in terms of the angle theta and the initial velocity v sub naught. And that's how that's done.